Okay, good morning. This morning there are two contests. There's LeetCode Biweekly Contest 30, and then there's LeetCode. Oh, no, then there's Codeforces. Then there's Codeforces round 655. I'm just gonna do the LeetCode contest. Hopefully it finishes really fast. I know it probably won't, but hopefully it does. But the Codeforces contest starts in half an hour later, and it goes for 2 hours. So I'm hoping this is gonna work out when I finish LeetCode. I'll do Codeforces. Wish me luck, and let's go. I think it was an easier contest than normal because I solved it in half an hour. So, I got 263rd place, right? So, let's just explain the problems and the solutions. Problem 1, reformat date. Given a date string in the form day, month, year, convert the date string to the ISO format. So, this is pretty simple. Since the year is always going to be the last 4 digits, it's given to be 4 digits long, we can just take the last 4 digits off and append that to our final answer. And then we put a dash. And then the month, we just find the index of the month within this month array. And then we need to add the day. So, we see if the day is going to have 2 digits or 1 digits. And then if it's 2, we just add it. If it's 1, then we add a 0, and then we add that digit. So I did that with some error handling. This is not the best way to do, obviously, but it worked. So yeah, that's how you do it. It's a pretty simple problem, really. Problem 2, range sum of sorted subarray sums. Given the array nums consisting of n positive integers, you compute the sum of all non-empty continuous subarrays from the array and then sort them in non-decreasing order, creating a new array of n times n plus 1 over 2 numbers. Return the sum of the numbers from index left to index right inclusive in the new array. Since the answer can be a huge number, return it mod 10 to the 9 plus 7. Since the input size is pretty small, it's actually only 10 to the 3, we can actually just make the array that they describe here in n squared time. And the way we can do that is we can find sum of subarrays really quickly using prefix sums. And then after that, once we created it, we can just sort it. And since the array is only n squared, that's going to be 10 to the 6, and that's going to be about 20 million. I know that's cutting it close. It's cutting it pretty close, but 20 million, LeetCode can handle that. So we sort it in n log n time, which is actually n squared log n time, which is enough. And then after that, we just find the sum from left to right, because that's going to take no more than n squared time, because the sorted array is, after all, only going to have size n squared. Return it. I remembered to return the mod. If I didn't, I'd probably have another 5 minutes to my time. But yeah, this is a bash problem. You just bash it. But you also have to use prefix sum, so I guess there's a little bit of algorithms stuff in there. Problem 3, minimum difference between largest and smallest value in 3 moves. Given an array nums, you are allowed to choose one element of nums and change it by any value in 1 move. Return the minimum difference between the largest and smallest value of the nums after performing at most 3 moves. So changing it by any value just means we can take one element and change it however we want. But essentially what this means is we can change it to the value of any other value in the array, which is just equivalent to removing it, because the final answer doesn't care about duplicate numbers, so we can just assume that we can remove at most 3 numbers. And I actually did a pretty detailed solution. I realized there's a better way to do it now. Basically, what you do here is you sort the array, because this doesn't care about order. So once you sort the array, you want to find the minimum range after deleting 3 elements. So the best way to do this is to delete off the end, off the largest values, or delete off the smallest values. And since there's only 3 numbers, we can take 3 off the end, or we can take 2 off the end and 1 off the beginning, or we can take 1 off the end and 2 off the beginning, or we can take 3 off the beginning. So there's only 4 cases here. And I actually got 8 cases because I cared about order, which doesn't really matter. But you can just sort the array, take it off the end or take it off the beginning, such that they sum to 3. And you go through all 4 possibilities, compute the range afterwards, and then you're done. We have 1, 5, 0, 10, 14. Sort this, it becomes 0, 1, 5, 10, 14. Okay, what we do here is we have to consider 4 possibilities. We can either remove 5, 10, 14. That means we're left with 0 and 1. That's a range of 1. Case 2 is we remove 10 and 14 and we remove 0. That leaves us with a range of 4 because we have 1 and 5. Case 3 is removing 0 and 1 and 14. That leaves us with 5 and 10, and that's a range of 5. Case 4 is removing 0, 1, and 5. That leaves us with 10 and 14. That gives us a range of 4. And the minimum of all of these is 1, so you can just return 1. I think this is a pretty simple problem. I did it in a bad way, but the way I explained it is correct. Yeah. Problem 4, Stone Game 4. Alice and Bob take turns playing a game with Alice starting first. Initially, there are n stones in a pile. On each player's turn, that player makes a move consisting of removing any non-zero square number of stones in the pile. Also, if a player cannot make a move, he or she loses the game. Given a positive integer n, return true if and only if Alice wins the game, otherwise return false, assuming both players play optimally. Yeah. This is just a classic dynamic programming problem. The code's actually pretty short. Basically, this is a 1D dynamic programming DP array. Basically, it's just an array of booleans describing if Alice is going to win if she starts first, given that many stones left. So the recursion is going to be if you start at a number n, you remove all possible square numbers such that you're left with a positive number of stones or 0 stones, so a non-negative number of stones. And if at any of those points you can make your opponent lose, so if the array is false at that point, once you remove a square number of stones, this means you can win. So that state is going to be a win if Alice starts on that move, if she can force Bob to lose on the next turn. So this is the dynamic programming transition, and at the end we just return the value of the array. So this is a pretty classic dynamic programming problem. It's not that hard. So I feel like today's LeetCode contest was easier than normal, probably, because I got rank 200. I mean, like, that never happens. I mean, that happened like twice, but yeah, it's pretty good. Glad I solved all 4 problems, but it's honestly really easy. Like, sub 10, come on, sub 10. It's like, if they can solve under 10 minutes, it's probably easy. And so that's today's contest, and I hope you enjoyed it. Thanks for watching. Goodbye.